Hello everyone, I'm kanybek duisheev, PhD student in Computer Science and Engineering faculty. Today I'm going to deliver a speech related with my PhD studies, which includes title and goals, and then perspectives, and of course what tasks have been accomplished so far. Then finally the results as well. So as you see here, the title we designated with our supervisor is developing of a method of synthesis of multi-loop LC circuits with predefined resonance frequencies. Let me briefly explain how huge this title contains a meaning in my thesis study. So this topic contains one part of the engineering field. Meanwhile, it's one of the newly emerging studies among the electrical phenomena, and we think its novelty and tough calculations will of course have significant contributions for the engineering area in the future. And it's actually devoted to identify loop eigenvalues with predefined branch values. And then in order to go deeper with our study, will of course be exploited by MATLAB program to use and calculate, make some synthesis procedures throughout multi-loop linear circuits. Special methods and techniques applied in order to analyze randomly selected circuit examples. So this is the tasks that we have already finished with our supervisor, Dr. Melnikov. First, we understood and investigated the topicality of our research. Then we set goals. Then, based on the plans, we defined problems and found solution methods. Of course, we developed some special programming codes to make it easy and attain our goal in a more sophisticated way. Then we worked with small and large scale examples. So we picked up a variety types of examples to make sure that our method will work. And then we analyzed, synthesized these circuits. Finally, we are about to conclude our study. So these are the circuits we used in our theory part as well as in practical part. As you see here, they are not simple or low-level circuits. They are much more sophisticated, complex, and which contains tens or more than at least 5 loops. So this circuit in which have 5 branches and 5 nodes. Let me briefly explain how we go through our thesis study by applying these circuits. So one of them is this 4-loop circuit, and these equations is part of the calculation methods throughout the study, and which helps us to find exact solutions of our initial aim. And so to solve these circuits, we had to first set our loop branch matrix form, and then it looks like this. Take some transposers and multiply it by the loop branch matrix form, and finally find the angular frequencies of each loop, and then apply some MATLAB codes to finalize it. So as you see here, this is a part of the MATLAB code which gives us the results. And after calculating these results, we can easily see that our topic title is actually fits with our calculations and the results. So calculating eigenvalues, what does it mean? It means eigenvalues is actually a tensor or linear algebra phenomena in which each loop contains in the circuit its own certain eigenvalues. At the same time, in engineering field, it is called resonance frequency of each loop. So what do we mean here? So if we give certain values at the beginning of the calculations, and then after applying voltage to our circuit, we can easily get the same values from the branches after applying voltage. It means that the predefined values can be taken from the output as a resonance frequency of each loop. So in order to calculate, to make it exactly correct, we have some criteria and cases. We have two cases for every circuit. First one, when this M is called number of nodes and R is equal number of principal branches. The first case, if number of nodes are bigger than equal number of principal branches, we will have at least one predefined eigenvalue from the output. It means that if we apply 4 principal branches for the circuit, for this circuit, we will definitely get one of the branch values from the output. The second case, what else if the number of equal branch values are bigger than number of nodes of the circuit, for example 7. So according to this simple equation, we get 3. It means that we will have 3 predefined resonance frequency values from the outputs. That it means that when we apply these similar values at the beginning, we will get at least 3 of them from the output. So that's why we call it analysis and synthesis of predefined eigenvalues in multi-loop LC circuits. As you see here, we applied these 7 equal number of branch values, and obviously we got 3 of them. So our method and theory is really fitting with this equation and results. And graphical representation as well as is suitably available. You can see that the encircled areas show that the square roots of the outputs, in order we took square roots in order to make it smaller scale. And then of course if the circuit is gradually increasing, the results will be also increasing, and the calculation also take much more complex, tough procedures. And to accomplish it, we developed MATLAB code, simple MATLAB program, but it takes a bunch of statements and decision codes. So there is no any problem with even the circuit number of loop. In the circuit, number of loops is whatever the value. For example, 15 or 20 or 10 loops. No matter how big it is. So this program can easily calculate every dimension of circuits. So this program contains actually identifies actually with predefined loop resonant frequencies, then calculates and synthesize number of equal branch values, and of course detailed analysis of each loop eigenvalues. And this is another example, as you can see, which contains 13 branches and 8 loops. So what did we do here? We assigned again 7 equal branch values, and if the number of equal branch values are more than the number of nodes of the circuit, we definitely get according to this equation some predefined values from the output. So here 7 minus, and number of nodes is actually it's here 8, and then how many give? 1, 2, 3, 7 values. 7 minus 8 minus 7, of course, is it is 0, but for the theory that first case states that if the number of principal branch values are equal or smaller than number of nodes, we will definitely get at least one predefined value. So we will get here 1, and others span between the lowest and the maximum value of branch values. Here from between 2 and 12, because we have how many branches? 13 branches. And then finally, so far we have completed and published 3 articles in 2 different journals, and the written part is worth 90 pages, and we tested and worked on large scale electric circuits benefiting from MATLAB tool. We have analyzed and synthesized through this program, and finally anticipated expected results. We are going to write, we have to write more than 100, maximum 110, 120 pages software, and then we are planning to work a couple of complex circuits to be sure, and then we have to submit in the very next 2-3 months. Thank you very much.